Hello everyone. Welcome to the Community Shelter Resilient Shelter Division. My name is Nivedita Paulraj and I am the jury coordinator of this division. It's my job to keep you on time and I'll be taking this very seriously. Our finalists have put in a lot of hard work. They submitted their project reports about a month ago and today these teams will present their work to the jury. The Community Resilient Shelter has three jury members. We have Alok Deshmukh. Alok Deshmukh is a co-founder and the MD at Superhuman Race Private Limited, a startup at the intersection of technology and sustainability. Alok also has over 20 years experience in sustainability and integrated design of buildings. Hello, Alok.
Hi.
Hello.
Next, we have Anamika Prasad. Anamika Prasad is an architect with a specialization in energy efficiency. She founded environmental design solutions and works in the areas of energy simulation, building codes and policy, and green building certification. Hello, Anamika.
Hello, good morning to all.
Our third jury member is Surya Kakani. Surya Kakani is the former Dean of the Faculty of Architecture at CEPT University, and his firm practices efficiency in operation, minimizes waste, and matches form and expression with construction systems. Hello, Surya.
Hi. All the best, everybody.
Yes. These jury members have had over 2 weeks to review the reports submitted by the teams. They have looked at your work in detail and have already assessed your entries for the 10 contests of the decathlon. Students, your presentations will help them hear your narrative. They'll assess your presentation and your mastery over your solution through the Q&A session. They may revise their scores based on what they hear from you today. Our first presentation is from Team Shunyam 2.0. They have worked on Project Nerel in Mangalore. The project partner is Albuquerque Hotels Private Limited. So let's do a quick AV check for our presenters. Hi Apurva, can you turn on your mic and say
Hello, ma'am.
something?
Good morning, ma'am.
Yeah, that's great. Hello Akshay, can you turn on your mic and say
He-
something?
Hello, ma'am. Good morning. Good
Yeah,
morning, everyone.
great. Hello Vishwas,
Good
can
morning,
you?
ma'am.
Good morning. Okay. So team, please share your screen and go into presentation mode.
Yes, ma'am. Good morning, ma'am.
Are you in the presentation mode? Have you shared the screen?
Yeah, is my presentation visible?
Yes. So, um, team, you will have 25 minutes to present your work to the jury. At 20 minutes, I'll ring a signal like this. You won't have a 26th minute. So, which means at 25 minutes, I'll ask you to stop and end your presentation. After that, we'll have a 15 minutes for a Q&A session. Please keep your answers direct and to the point. And okay, team, the
Okay, can we?
stage is all yours.
Yeah, thank you, ma'am. Good morning, one and all. I am Apurva. We represent Team Shunyam 2.0 and will be presenting our project Nerel, a community resilient shelter. Nerel, which means shadow in Tulu. Nerel is our intervention in Mangalore, situated in the coastal city of Karnataka. We are technically neighbor of God. We will be running through 8 points in our presentation today that summarizes 10 competition contests and our journey designing Nerel. The Intergovernmental Panel on Climate Change in 2020 announced Code Red for Humanity, and this summer we are able to see and feel the gravity of the warnings that have been given to us. We are living in a climate crisis as of now, and it's only going to worsen from here if we don't take any immediate action. Very recently, this meme is catching up a lot. While it's got a hilarious side, it is undeniable hard reality that our generation is facing. Let me make it very clear. This is the coldest summer of the rest of your life. Most of India forms a peninsula, which means it is surrounded by water on three sides. The peninsula India comprises the diverse topological and climatic patterns of South India. The peninsula is bounded on the west by Arabian Sea, on the east by the Bay of Bengal, and on the north by the Vindhya and Satpura ranges. But these coastal cities are endangered owing to the climate change. This is further supported by latest report from NASA, which predicts that cities like Mangalore could be half a feet underwater owing to rise in sea level. The Mogaviras, a fishing community especially, is affected dramatically. Mangalore is bordering city to Kerala and is prone flooding very often. Many flooded houses along the stretch are deserted. People living in this area are now seen often relocating during monsoon season to avoid harsh effects of climate change. As per IPCC reports, the coastal city of Mangalore is expected to face impacts of climate change and rising sea level. Given the challenges, we have considered our site on the coast of Ullal. The site is home to indigenous Mogavira community, easily accessible to public, and has very viable problems which can be addressed by providing a community resilient shelter. Here are some hard numbers for your reference. Nerel is to be developed on 3 acres in warm, humid climate of Ullal, Mangalore. Our project has a built-up area of 3,500 square meters and can house about 200 people. The project will be occupied for 24 hours for 6 months, which is monsoon season, and for remaining 6 months it is expected to be occupied for 12 hours including weekends. We have done an environmental vulnerability assessment for our project and have considered various threats to our site. From the assessment, it was very clear that we need to take utmost care from the sea, floods, and pandemic. Our vulnerabilities includes river floods, cyclones, and soil erosion. We have devised various strategies to mitigate the disaster. For example, we are providing groins and breakwaters to avoid soil erosion on the site. In the initial state, Mogaviras live near riverbeds, large tanks, reservoirs, etc. The inland fisheries data show that still a large number of fishermen live near water resources. The places where present Mogavira villages are situated were shallow water swamps during the monsoon. Most of the people in Ullal belong to either Beri or Mogavira ethnic groups whose occupation mainly are beedi packing and fishing. Being in a warm and humid climate, it induces and supports growth of vegetation. Our site is blessed with variety of mangroves, coconut trees, jackfruit tree and so on. Unfortunately, in Karnataka, the mangroves which are major solution for mitigating sea floods have been reduced dramatically by 90% as compared to the date from 1987. The bathymetry map suggests that the coastline along Mangalore has a steep slope from the shoreline. Furthermore, this coastline is often the spot for low depression and results into sea cyclones of varying magnitude. The tidal range varies between 10 to 12 meters. This tidal current transport large quantities of sediment and may erode the bedrock. To counter this, Nerel uses appropriate design and foundation construction techniques in this area that prevents rapid degradation of the building. So, based on the climatic analysis for the site, Nerel design principles includes reduced thermal bridging with use of insulation in roof wall junctions, use of passive house windows, reduce WWR with adequate ventilation strategies, and reduce solar heat gains by appropriate shading strategies and orienting the longer axis of the building facing north south direction while providing appropriate shading. Nerel also follows an integrated design approach to achieve net zero energy. We considered having a lot to and fro to reach a consensus in our design. We have defined 8 broad goals for our project, apart from the 10 contests as suggested in the competition brief. The way we have defined these goals is to have a strategy along with the rationale. For example, we have a target EPI of 50 kilowatt hour per meter square per annum for our project, for which strategy is to reduce the cooling demand by reducing the radiative, conductive, convective heat gain for our building envelope. Further, the rationale we have is that cooling load accounts for 60% of the overall energy consumption in the building and addressing the high energy consuming parameter, which will help to reduce the overall building EPI. To achieve the said goals, Nerel uses specifications like orienting longer axis facing north and south, providing 30% WWR along with the use of double glazed windows to reduce heat gain. This is further enhanced by having overhangs, roofs, and wall insulation. Further, to increase energy performance, fixtures like energy efficient fans and light bulbs, occupancy sensors are used. Indoor air quality is maintained with ACs with air cooled chillers and air handling units. Each air handling units are equipped with air economizers. Considering the usage of spaces in a community resilient shelter, Neril has permanent and dynamic temporary zones in the building. The community kitchen and the dining, dormitory, and school daycare are designed to be temporary structures, while the hospital, the isolation blocks, along with the market and administrative office, are designed as permanent structures through the year, benefiting the entire community. The plan of the CRS is oriented with respect to the climatic analysis. The site lies partly in CRZ 1 and CRZ 2. To tackle this, the build forms in the CRZ 1 are of temporary nature, while the build forms in the CRZ 2 are of permanent nature. The plan is kept very simple with access along the site. The site consists of a market space, office, health cum isolation center, school cum daycare center, dormitory, and a community dining and kitchen. To the access to the site is without any barriers and facilitates free movement. The CRZ2 parts of the site consist of a health center, isolation wards, market space, and the office, which will remain functional even during the non-disaster times. While the CRZ1 will be functional when required during the peak periods or during any disasters. The space making in the site has adopted many contextual elements such as cuttays, which are basically talking spaces around a tree designed to facilitate communication and a source of relaxation for the people living there. The temporary structures walls is an assembly of steel frameworks with insulated JSW corrugated sheets. Since the CRZ1 has loose soil, the foundation was designed to fulfill certain requirements. For this, an innovative idea of using weld rings to support the foundation in order to allow the soil to be compacted in a place was implemented. On doing so, on doing several analyses, we came to a conclusion of filling the rings with different layers of aggregates in order to attain structural stability. The assembly is then bolted, erecting the columns and roof in place, and the wall modules could be then fixed by arranging the assembly in not more than 60 hours during the time of any disaster or pandemic. The roof assembly was designed to counter the strong winds and cyclones during the monsoon season. This assembly also helps to prevent the upliftment of the roof from the main structure. To achieve this, the roof behaves differently in two different cases. That is, case 1, when there is not much wind, the flaps will be closed and the water will be directed to gutter A, which is at the lowmost level. While case B is when there is much wind, the flaps will open to let strong winds pass, thus keeping the structure intact while the rainwater will be directed to gutter B, that is the uppermost gutter. Now coming to the energy performance, Niril has been able to achieve 67% reduction in EPI as compared to the base case. This is possible by using various energy conser- conservation measures like proper orientation, reduced window to wall ratio, window shading, wall and roof insulation, better window U value and SSGC, efficient HVAC, various sensors, energy efficient lighting, and ceiling fans. Further, we would like to show you how we have been able to achieve 67% overall reduction in EPI. This graph shows how much EPI reduction we are able to achieve for each block. For example, we have been able to achieve EPI reduction of 77% for admin block and so on. Additionally, we have been able to achieve 23% reduction in overall cooling load as well for our project. We have this high cooling loads as the site is in warm humid climate and has high latent loads to address. We have been able to achieve about 0.25 kilowatts of cooling loads per square meter for our Nerel project as opposed to the 0.32 kilowatt of cooling load for the base case. We are also able to stimulate how much cooling load we were able to reduce for every block. Over to Vijaya.
While 67% EPI reduction is seen with set strategies and even energy efficient solution, Nerel is further able to reduce 4% EPI with the use of solar panels and an additional 1% reduction using pavement tiles, bringing the overall EPI reduction to 72% as compared to the base case. Research and published data shows that in Mangalore, groundwater has gone 30 to 40 meters below ground. This brings us to our contest number 3, which deals with water performance. We have deployed various water saving measures like low flow flush, waterless urinals, other efficient plumbing fixtures, rainwater harvesting, using root zone treatment methods, grey water and black water treatment plants, and having an open well. This helps us in 42% reduction in water demands and 100% water demands being met on site. Furthermore, the pipelines of water supply pass through trenches all along the site. As water saving measures in Nerel, we use low flush toilets and aerators to regulate water flow. Hence, usage for potable water is reduced by 28% and usage of grey water reduced by 64%. Furthermore, we also have been able to meet the water requirements as per NBC. Furthermore, Karnataka is experiencing increasing temperature and heat waves year after year. In 2021, parts of Karnataka experienced a peak rise in temperature. Thermal comforts becomes a challenge in design. High performance, net zero buildings would not only minimize energy use but also provide low cost thermal comfort solutions to communities in rural. As per the results from Design Builder, we have been able to meet the monthly zone thermal comfort as per ASHRAE 55 simple model for our Nerel CRS project. Additionally, from the graph on the right, it can be seen that Nerel CRS demonstrates the unmet hours are below 300 as per ECBC 2017 for each building blocks across the year. This has been possible to achieve by using air economizers with appropriate filters and an enthalpy wheel to cater to high latent loads. Furthermore, we are also proposing a feet washing area as a design feature that will reduce the heat stress for our occupants. This also happens to be an indigenous design feature. We also have been able to absorb a reduction of 45% in our operational carbon and about 63% reduction in embodied energy for our Nerel project. We have additionally incorporated natural daylighting strategies in Nerel. Additionally, with the set window to wall ratio and proper orientation, we have been able to achieve maximum daylight in all the blocks. Two types of foundations are proposed for the site for permanent and temporary structures. The structures coming in CRZ1 have foundations that are bound by rings to keep the soil in place and aggregates to keep the structure stable, while the foundations for CRZ2 are regular RCC foundations. RH columns are erected on this foundation to which wall modules are fitted. Nerel uses supervisory control and data acquisition system, an integrated system to keep real-time check about how much energy is consumed on daily basis and whenever there is a problem such as leakage or excess use of energy, this system can control and restrict it. This in Mangalore is already implemented in smaller residential units and MESCOM will integrate this on an industrial scale within a year. SCADA has helped us improve the efficiency of the system. Additionally, time operated, bug related street lights with solar panels are used for energy efficient use of energy.
With thermal comfort is achieved on most hours with passive strategies. HVAC systems fitted with air economizers contributes to increased indoor air quality. These HVAC systems are used only when required. Communities in Ullal are highly vulnerable to natural disasters. In that case, the buildings become the first defense to communities. Disasters and resilient infrastructure are paramount to protect them from risks to their lives and properties. Food being the important source for survival in any disaster case, the site itself will behave self sustained enough to meet the food demands of the residents in small scale with the implementation of square foot gardening. In addition to its efficiency, square foot gardening is also popular because it conserves land and water. The composting will be done using the methods of composting, which will be further used to manure the gardens. Planting homegrown fruits are known to promote well being. We have identified ways of using the building during disasters and not disaster times as well. Along with solar panels, energy reducing pavement tiles become a source of renewable energy in Nerel, powered by footsteps. This has successfully helped us reduce our EPI by 1%. Mangalore, being in warm and humid climate zones, has an average annual relative humidity about 76%. In Nerel, this has been put to use for generating potable water using atmospheric water generators. Additionally, with the site falling near seashores, makes it easier to desalinate salt water with DIY desalination processes. Now, coming to the most important part, money. We have done our cost calculations and we have been able to achieve our project Nerel at 14% incremental cost as compared to our business as usual case. We also calculated our return on investment, which is at 14.5% and is almost twice as compared to the interest rates offered by banks today. We understand that Neril has 14% higher cost and is difficult to be accepted in the socio-economical setting such as CRS for the Mogavera community. However, we conducted an interview with our project partners and stakeholders where they told us that the cost is slightly higher but also is the market reality. They concluded it saying that they are very happy to have a construction cost of about 38,000 rupees per square meter as we are positively impacting the Mogavera community to a large extent. Additionally, the project partner was quite sure that he can get a green loan for the project. The wall and foundation modules being made with ready to use materials makes it significantly easier to replicate the assembly, which contributes to lesser construction time, further increasing the affordability of the project. This also means Nirral can be executed anywhere along the coastline with corresponding conditions. Data shows that about 250 million people live within 50 kilometers of the coast with 3,288 fishing villages, while there is a significant rise in fishing activities in India. With Niral's increased scalable aspects, the project can be a solution to keep these numbers up. So, in and all, though our interventions for Niril CRS community in warm and humid climate of Mangalore, we have been able to achieve an EPI of 520, which is 72% reduction as compared to the base case. We also achieved 100% thermal comfort needs and reducing cooling loads of 23% at the same time. We have 100% water demands met using the rainwater harvesting while reducing 42% water consumption. And we have gone as far as to tell you that we have 66% reduction in embodied carbon energy and 44% reduction in operational carbon energy. Now, you might be thinking that since Niril has such an amazing design and a reduction in energy and water, it must be costing a bomb. But let me tell you that Niril is costing only 38,489 rupees per meter square. This is 14% higher cost as compared to the business as usual case. We justify this cost by having an annual return on investment of 14.5% and ability to affect about 1,000 people of the Mogavera community. In this section, we would like to bring to notice to everyone that everyone knows the term sustainability. We are also aware about the challenges that we face in achieving the sustainability in the built environment. We also know that having a sustainability in built fabric will lead to benefits like high work productivity, better living conditions, improved longevity, and the list goes on. Then what is it that is stopping us? We think the answer is lack of realization as the mask of deception falls off the face of humanity, unveiling the grim realities of human actions in which everyone will be a casualty and no one will be exempt. Yes, although we are many, we are also one. And so, in the final analysis, we can win this war. And as we are toward the end, but end is only the beginning of calm before the storm. Remember, choice is solely ours and yours to choose ecosystem over ecosystem. We thank you for the opportunity to present our Nerel journey.
Ma'am, you're on mute.
Thank you, team. You finished well in time. So let's hear the jury comments and take questions from them. Alok, I'll start with you. You can ask your questions.
Yeah, so thanks, Nivedita, and congratulations, Apurva, Akshay, Ayush, and Vijaya on making it to the finals.
Thank you, sir.
Um, I enjoyed reading your report, and I think you have, uh, quite a few good things that are going in your project. One thing that I was not clear about, and I was hoping to see that clarity in the presentation that I wanted to ask, is so are you hitting a net zero energy target? It seems like from the presentation I could gather that you are water neutral, but it is not clear about whether you are hitting a net zero energy target from your presentation. So if you could just help me understand that, it would be helpful.
Hello. Hello. Yeah, we are able to achieve net zero energy since this is a community resident shelter, and we have different blocks, and we have simulated for the each block, and we have got the EPI reduction for individual blocks, and since due to that we are able to get the EPI reduction, which I have already seen in the graphs we have given. So we have simulated with Design Builder and rechecked it with IFC. After that, we are able to achieve this reduction. Yeah, our cooling load, we have a bit less reduction since we have a lot of latent load coming into our design, and also different blocks operate at different hours as the local community have suggested us. So based on their interview and their responses, we have set operational hours for each individual block. So it may be the kitchen, or it may be the admin, or it may be the hospital, etc. So based on that, we have set the operational hours, and from that we have simulated through Design Builder and rechecked it with IFC, and we have gotten the results in the presentation you have seen. So
Okay, thanks, Akshay. But so, if I remember correctly, you said 67% reduction through efficiency and load reduction from the EPI,
yes.
and then 4% from solar panels and 1% from PaveGen EPI reduction. So, I'm still
Yes.
kind of curious about how those numbers add up. So, over a period of a year, for kilowatt hours consumed versus kilowatt hours produced, you are reaching net zero for the entire project, is it?
Yes, sir. Yes, sir. Because since the first graph which you have seen was if at the slide 21, the it was only the energy efficient measures which we taken. That may be the orientation
Akshay,
or HVAC, etc. Slide.
Akshay,
Yeah,
if I may
yeah. This.
interrupt, we are not achieving net zero as of now. We have been able to reduce the APR. It was hard to reduce because considering the climate zones and the cooling loads that we have. So we have just seeing a reduction of 72% as of now.
Okay, thank you.
Thank you, Alok. Thank you, team. Anamika, it's your turn now.
Congratulations, team. You've done an outstanding job of setting the context, whether it's sociological or, community based activities in the area, and what kind of challenges your particular site faces. So, after, your presentation, I got a lot of clarity on that, and a good job on that. Um, my and similarly on the energy numbers too, your narrative that you submitted did not have the clarity that you brought about in your presentation. So I could now make out that okay, your epi is at 50, which I would have liked to see, like a step by step kind of a narrative that dealt with each ECM and the reduction because of each of the measures, kind of like a shoebox analysis. But I think the presentation has brought the clarity that was not there in your submittal. I like your you've put in a lot of effort into designing some of your structural systems, and your thought process is well articulated. The well ring foundation, um, the adaptable flaps on the roof, the modular metal walls. So great job on working that out very well. Um, what else? And also, I was very happy to see you mention the SCADA system, and talking about grid integration. So that is a big plus. Um, yeah, good job.
Thank you, ma'am.
Thank you, Anamika. Surya, over to you.
Yeah. Yes. Thank you, Nivedha. And great finally coming face to face with this team. Great job. It was quite a pleasure seeing some of the things that you did and how you took stage one, I mean, delivery one, three, two, three, four. I mean, you took the comments, and towards the final, also some of the comments you've been able to kind of, which shows that you're actually trying to, you know, take forward what the reviewers have been giving you as input. So that's a very, very good sign, and because there's no building or there's no project that is 100% proof of all the issues that we're talking of. The moment you build, you're unsustainable, in short. So in that sense, I think a lot of effort worth is also told earlier that you got this small, very interesting, whether it is paved in tile, whether it is the detail of the roof, whether it is the foundation, the kind of structure that you've employed. I think there are lots of innovations and a lot of inputs here that one can take forward. Desalination. So all that said, what one would want to understand is, and also I must really, I think the larger idea to me also was very important. I felt that where you're putting together really a community space, which is whether it's eating, hospital, various other facilities, the community can come together, especially during a disaster time. We would need a lot of these kind of functional spaces, though some of the functional spaces, architecturally speaking, could have been kept in mind in terms of how it evolved in keeping the culture of the place, the fishermen, their life, the kind of outdoors that they are normally used to, and how important it is for them to have how much of climate controlled space, the proportion of climate controlled space to the other proportion that otherwise culturally that they are used to, because they would want to have to go back to their normal lives. And so that part is something that you may want to kind of keep in mind going forward. As you're always see, yes, you need a net zero building. At the same time, could you have reduced uh, its its need for energy, the amount of energy that you would need to keep this building going? It's just an understanding of the culture of the place. And otherwise, what you've done to reduce it is definitely very powerful in the but in the first place, if you were to think otherwise. One question that one really wants to understand is the ROI. You mentioned 14.5% is ROI. I'm curious as to why do you look at a disaster shelter as requiring an ROI? So just wondering where that comes from and how would you want to talk about that? Return on investment. You're looking at a disaster shelter and you're talking about a return on investment. So I'm just curious.
Yes, sir. The rate of interest is 14%, but then it is accepted by the project partner, and he also told that he would be taking a green loan for the same.
How do you get the return on investment? I'm just curious. Even the
Um,
what is the
so
return that the project partner is looking at?
the
You're
project
looking
partner
at 38
wanted to,
crores.
yeah. So basically, the project partner wanted return income as well, and part of the building will be functional throughout the year. Like for example, the hospital and the isolation wards and the marketplace that we are proposing, it will be functioning throughout the year. So that's what we are talking about over there.
So these are basically spaces which are privatized in the sense they're rented out or they're.
Some of these
Uh,
spaces, yeah.
so I think this has not come across very strongly in your presentation, which I think is an important point, which you could actually make, that you're actually subsidizing the shelter through certain other marketplace requirements of a hospital, of a marketplace, or a cold storage, or whatever. This is something that you should actually have and emphasized a bit more in the presentation. That would be valuable
So,
because,
may I
yeah,
interrupt? The thing is,
please.
the hospital will also function during the non-disaster times, while Summer Sands, our project partner, is having a resort set up there. So he told that he would be using the CRZ1 zone, that is the community kitchen or the community dining and the parking for some other purpose. So that's how the income is still generated at non-disaster times, and that's how he would be getting the one of the ways of getting the paybacks, return rate of interest.
Yeah, no, that's, I
Yes.
think, very well expressed. It should have been put together also in the communication in this, because this is very, very important. Because one of the things that comes across very strongly in your project is A, the energy, and two, the cost of the project, which is 38 crores. So, one kind of needs to get that clarity that, if you're talking of 38 crores, you're really talking of what you just expressed, which is, I think, yeah, I would take that as a positive, that there is a balance of some kind. So yeah, and I think that's all I have to say. Otherwise, there's already been nothing you've all presented, and we've already commented quite a bit. One doesn't want to repeat. And all the best. Thank you.
Yes, sir.
Thank you, sir.
Yeah, thank you.
Thank you, sir.
So
Thank you, sir.
I just, if we have
Thank
a
you.
minute more, I just wanted to understand. So if you're spending 38 crores and getting a return of investment of about 14 or 15%, it means that the community center is making 5 crores a year. Is that, I mean, is that what your calculation suggests?
38,000 per, it is per square meter per annum. Yeah.
Okay. Okay.
So, thank you, judges, and thank you, Team Shunyam 2.0. Uh, let's take 5 minutes to get ready for the next presentation.
What's next, Nivedita?
It's Team Styrian.
Okay. All right. Thanks.
Yes. Okay. Our next presentation is from Team Styrium. They have worked on a project called Visraya in Assam. The project partner is Selco Foundation. So let's do a quick AV check for our presenters. Hi Komal.
Hello,
Can you please turn on your camera?
one second. Yeah. Okay. Yes, yes.
Yes, great. Hi Monica.
Hi.
Yes. Hi Anuja.
Hi.
Hi Manasi.
Hello.
Yes. So team, can you share your presentation and go into presentation mode?
Yes. Just a second. Is my screen visible?
Okay.
One second. Yes.
Sure.
Is my screen visible now?
Yes, go on to presentation mode.
Yes. Yes.
Yes. So team, you'll have 25 minutes to present your work to the jury. At 20 minutes, I'll ring a signal like this. So, you won't have a 26th minute. So, which means you'll have, at 25 minutes, I'll ask you to stop and end your presentation. After that, we'll have a 15 minutes Q&A session. Please keep your answers direct and to the point.
Okay.
Okay, team, the stage is all yours. All the best.
Thank you. Am I audible?
Yes, you are. Yes, go on.
Hello. Am I audible?
Yes, yes, Komal, you're audible.
Yes,
Okay. So, should we start our presentation?
yes, you can start your presentation.
Yes, thank you. Hello everyone. Team's Therium introduces you to Visraya, meaning shelter for protection. In our case, a community resilient shelter designed for Machine community in Lakhimpur district of Assam. To design this, Team's Therium comes together, which consists of 12 participants from masters and bachelors. With this diversity in curriculum, our team tries to look at competition's requirements through various lenses with our faculty lead, Prajakta Kulkarni ma'am. Our site lies in north part of India. Flood havocs Assam every year during monsoons. Assam is the land of two mighty rivers centering the Brahmaputra and Barak. Each year, these two rivers causes floods in vast areas of Assam. In Lakhimpur, there are around 180 villages in the 180 households in these villages, and they all fall under flood-prone area. The nature of the area has rendered the communities disconnected and difficult and has left them with the limited alternative income sources. Lakhimpur experiences warm, humid type of climate. According to the chart, it falls out of comfort zone for the most time of the year. Dehumidification is required to bring it in the comfort zone. Our site is located on the warm plains with high levels of humidity and heavy rainfall. This brings in water from hills to plains with debris and erode the soil. To resolve these and overcome these challenges, we aim to provide sustainable design to optimize the use of water and energy, make it resilient and adaptable structure for alternative uses during non-disasters as well. To achieve comfort during efficient solution using efficient solutions, effective reduction in operational and capital costs of the building, to make space safe for women, kids, and provide hygiene and health. As a team, we intend to follow integrated design approach. whereby we have set goals for our project in line with our project partner ideas. The process started with disaster risks in India and management by the state, followed by the site specific study on the disasters and climate. We then studied local methods and building materials and their stability to withstand disasters in past years and their architecture styles. After the brief study of the villages, some of the immediate impacts of the flood mapped are on transport, availability of resources, food, sanitation, and shelter. A preliminary base case analysis with the daylight, energy, and ventilation were analyzed for the design options. Comparing the parameters, this design was the feasible to go ahead with. Project Visraya is designed flexible enough to be used during non-disasters. The site area is 9,500 square meter with a built-up of 1810 square meter. The site is flat with access road on the northern side. The wind flow and the water flow in the site will be prominently from the northeastern direction. Selecting the site location above the main river have helped us reduce the direct water flow in the site. The shelter will otherwise help build the community by providing agro processing center and empower women in the village by providing weaving unit and thereby creating more employment opportunity in the shelter itself. Here, the cattle and the humans enter the site from the main access road. The periphery of the compound wall are kept at least 5 meters away from the shelter. uh, periphery and the compound wall where the trees have been designed are kept at least 5 meters away from the shelter. The cattle stay is in the northwestern corner of the which is used as a dairy unit which take cattle shelter during the disasters. The shelter is raised on the stilts, giving space for the livestock or as pets resting space. Medical room, logistics, and kitchen space have ra- ramp access to make the shelter universal. Logistics, seed bank, and the toilet blocks are clubbed together to have a common service entry. The building is opening towards the wind inflow, and the central niche is used to maximize the continual airflow of the building, continual airflow in the shelter. Weaving unit located to receive the most daylight in the southern corner. The agro processing center, weaving unit, and logistics and seed bank will help in enhancement of the mission community. The SAG, crash, and medical rooms functional during non-disaster are support spaces, and toilets will be used as a community shelter which will resolve the lack of sanitation problem. So the core guiding principle in our design was to reduce the mechanical energy, use the naturally ventilated while the occupants thermally comfortable and safe environment. The shelter is used to design the flexible during to accommodate 200 people, and other spaces are converted according to their needs. The cattle are shifted to the shelters above ground. The periphery of the site is designed with water channels and ridges around the site. The STP is located above ground to avoid water contamination at the southern end of the site. Management during disasters. Preparation for the disaster during scenario include early warnings, provide first aid to the injured and rescued, for 24 hours medical rooms to take care of children, women, and disabled. SHG spaces converted to a women's room, preparing medical units during disasters and post disasters, and stocking community kitchens with supplies, moving equipment and baggage to the logistics and weaving room, while laying the mattresses in the multipurpose hall, clearing out spaces for additional occupancy, and lastly, moving the cattle to the shelter. Here, a building is elevated on the concrete stilts to avoid water inflow and enhance greater air movement. Woven bamboo mat made by communities are used in the partition walls. Louvers in the central court, uh, louvers in the central courtyard for the continual airflow in humid climate. Engineering and operations. The material palette includes stone foundation, substructure is in concrete column and flooring. Bambusa balcoa can be used for the load bearing structure, such as walls, partitions, and columns. Simple methods of treating and seasoning bamboo used locally, like water and smoke treatment, are carried out prior placement and further treated with CCB to reduce the effects of decay and insect infestations. This increases the lifespan of bamboo by up to 20 to 25 years. Bamboo and cane exterior walls plastered with mud or cement with fine river sand. The outer edge of the structure is constructed with a hollow adobe block embedded with bamboo column till sill level, and above sill level it is a bamboo and cane wattle dog. Interior walls, interior partitions clearly will be local available ikra reed panels or bamboo woven mats by the communities. The roof consists of wooden trusses, rafters, and purlins of bamboo and converting the bamboo corrugated covering with the bamboo corrugated sheet with large overhangs. The truss takes up most of the load. The structure is analyzed based on the StatPro analysis, based on the performance of the structure detailing taken forward. The depth of the overhang is further calculated using solar azimuth and altitude angles. Using the vertical shading angle, we got up to 1.3 meter depth of the overhang. The stilt analysis was performed on CFD, shape and pressure handling capacity of each type of slit was analyzed. Three types of stilt shapes, circular and rectangular, which is commonly used, and another shape formed by tying 6 to 8 bamboos together. That is the aerofoil shape of the bamboos was run together, and water pressure and velocity analysis. Based on this analysis, we choose to go ahead with the circular stilt. The circular stilt could handle same pressure on all surfaces and could withstand floods. The time period to complete this whole shelter, as suggested by the project partner, is about 6 months. Over to you, Monica.
Yes, the shelter is connected to the communities within 1000 to 1600 meter radii, providing sufficient supply of goods required for the rescue. Then use of the local materials in the construction of the shelter and understanding the local labor. Then creating resilience in nature by creating ridges to prevent the damage from the debris and the harsh flow of flooding water. Elevating the structure to be resilient during water inflow, relying completely on solar power backups as the shelter is going to be off grid. So use of rain screen detailed window can withstand the wind and interior finished materials that can dry out and not require replacement. The windows are protected by mosquito mesh, chicken mesh, bamboo grills, and the window shutters, and large overhangs to protect from the rainwater. Since we have heavy rainfalls for about 3,500 annually, the louvers have been designed to keep the water out and allow continual airflow to provide comfort along with the ceiling fan. So the louvers reduce the air velocity from between 25 to 50%. Resilient metrics. The passive performance of the shelter, that is 5,745 hours of thermal comfort, that is 66% of the year it receives is thermally comfortable. Energy storage, so 40 numbers of solar batteries with storage capacities of 2 days each are provided. Then for medical support, allocations of medical paramedical staff as per the law, as per the FLEWS. Then communication pre and during the disasters, the equipments are checked monthly, and the maintenance of all the equipments are according to the manual. Water sufficiency, drinking water and the water use is for 2 days period. The food supply is for 3 days, and the stock of dry fruits are for 1 and 2 months, and so things like household items, baby food, petrol, diesel, medicines during the times of disaster. For cattle, the arrangement for animal camp and fodder is organized for 10 cows and 10 pigs. And for emergency kit, provision of 2 boats and 1 ladder and torches. For the energy performance, the design aim was at optimizing the opening to to increase the daylight ingress, increase the cross ventilation to facilitate comfort in warm and humid climate, efficient lighting system, reducing efficient loads, providing efficient systems to achieve resilience during the time of disaster. So we analyzed a few options to reduce the resultant EPI and provide maximum thermal comfortable hours. So firstly was the material selection. So for wall, a combination of bamboo and cane wall plastered above the sill was used with a U value of 0.93 watt per meter square Kelvin. And for the roof, bamboo corrugated was used on bamboo truss having U value of 2.56 watt per meter square Kelvin. Secondly, the use of mixed mode operation with natural ventilation. So the spaces with ceiling fans and natural ventilation to enhance the use of available comfort hours from the outside environment. So the comfortable hours achieved for the proposed case was 5,745 hours, that was 66% of the year. The humidity levels were controlled by providing the ceiling fans and strategically designing natural ventilation. The air change observed for the spaces are as depicted in the presentation. The proposed design does consist of all the ECMs mentioned above, and the resultant EPI is of 38.06 kilowatt hour per meter square a year, which is around 52% less than the base case and 31% less than compared to the ECBC benchmark. For the daylight, we did the daylight analysis to maximize the natural daylight and reduce the artificial lighting. So, based on the daylight analysis, spatial design autonomy was increased by 41% in comparison to the base case, and the total LPD that was achieved was 6 watt per meter square. The 97% of the floor area received at least 300 lux for 50% of the occupied hours. Then coming to the solar PV system, optimizing the solar system design was designed by the provision of on-site renewable energy sources, making it completely off-grid, living autonomously without the reliance on the public utility for power. So indicative solar design for community resilience come agro-processing center and dairy unit was given by Selco. The solar design provided a hybrid model and will be connected to the grid for battery charging during non-availability of solar. The batteries and the inverters have to be placed in a non-ventilated space away from any water spillage. Only one machine will be used at a time, so both the machines will not be running simultaneously, and the batteries can be placed in the logistic or the packaging unit. Efficient lighting fixtures are used to reduce the lighting load. Solar energy products like the rice water huller, the solar water pump, and the solar lighting systems are used. Integrated energy centers are installed by Selco, which are essentially solar powered independent service centers in the rural spaces where a combination of energy services such as lighting, mobile charging, charging batteries, etc., can be provided on daily or monthly basis. Over to you, Mansi.
We plan to design a net zero water structure. The site has no access to the municipal supply, but as there is abundance of rainwater, therefore we plan to use harvested rainwater and treated water to suffice our water demands. Water is collected from roof surfaces. First process of screening is done at the rain gutter. It is next filtered through the slow sand filters as they require little or no mechanical power, chemicals, or replaceable parts, and they require minimal operator training and only periodic maintenance, which makes it more appropriate and affordable for our site. The filtered water is then stored in the underground water tank. The extra water will overflow from the tank into the borewell. The water from the tank will then be used for washing, cleaning, and other purposes. For drinking, the water is further purified using bamboo charcoal filter. The grey and black water generator is sent to the sewage treatment plant of capacity 19 cubic meters to be reused for flushing and cleaning. As the area is prone to severe floods, we decided to use packaged STP for the site, which will be partly above ground. That is, 7 feet tank will be 4 feet above ground so that the flood water will not touch the lid. Packaged sewage treatment plant is an innovative and truly versatile system for the effective treatment of wastewater. As per NBC, the water consumption in liters per day per person was 135, but with the use of low water fixtures and using Indian commodes, we have reduced it to 95 LPCD, that is 30% less than the baseline consumption. The annual water consumption is 3360881 liters, which is sufficed by using harvested 3442909 liters of rainwater and 15 to 6531 liters of recycled water, which shows that we have achieved net zero water sufficiency. The extra rainwater collected is then used to recharge groundwater. The underground water tank is sized by calculating water requirement for 2 days, and overhead water tank is sized by calculating 1 day requirement. The capacity of STP is estimated using 90% of the total domestic water demand. During the non-flood time, the total number of occupants will be 100. The filter water will flow to the borewell and then we directly use it for drinking and washing purposes. While during the flood times, the borewell water will be contaminated. Therefore, the filtered water will directly go into the underground water tank and excess water will get overflown into the borewell. The number of residents will then be 200. The abundance of rainwater and affordable treatment practices has made it simpler to make the structure net zero water sufficient. Health and well-being, waste management. Sandbags are used to prevent flood water from entering homes and other buildings. By blocking the water flow, the sand in them and the bag itself can become contaminated with chemicals, pathogens, humans, and animal sewage from the flood water. No reuse of sandbags in areas where people may come in contact with them. For women during non-disaster, there is SHG and creche for women working during non-disaster times. The same SHG and creche can be used as women's room for kids feeding and special care room during disasters. A pure water tank for drinking purpose is provided. Multi-purpose SHG and creche spaces and 3 beds for medical emergency. Cows pigs rest during non-disaster times or in summer times under the structure and stilt level, and during the monsoons or disasters they are shifted to the shelters provided above the ground. The provision is made for cows and pigs separately to avoid diseases and maintenance. During the disaster period, 64% of thermal comfort hours are achieved while designing with respect to passive strategies using cross ventilation and stack to dehumidify the space. The comfort hours achieved for the proposed case are 5,745 hours, that is 66% for a year. CFD analysis on ventilation gives a result to indoor ventilation velocity up to 1.8 to 3.77 meter per second. Natural light in an all the habitable rooms receive good daylight, that is above 3% average daylight factor. 97.3% of floor area received at least 300 lux of 50% of the occupied hours. Over to you, Anuja.
Scalability. The target market selected for this project based on the site location and disaster management plan are people worst affected by the floods and pandemic. The community resilience shelter will otherwise help build the economy by providing agro-processing center and empowering women in the village by providing weaving unit and thereby creating more employment opportunities in the shelter itself. This ensures ease of maintenance and functional during disasters. The self-help group and center can collaborate with different government missions and help improve maintenance. Assam Disaster Management Manual 2015 has guidelines for gender sensitive approach. Modular multiplication for large-scale implementation. The scope of the module is just limited. It's not just limited. It can be constructed on stilts by replacing bamboo with mild steel according to the context. We can also keep the bamboo structure and fix panels to the existing framework. This module can be used in other disasters like cyclones and heat waves with relevant modifications. The construction techniques are vernacular, so the communities can self-develop and the structure, which will also create a sense of ownership. The plan can be divided into simple modules. When the project is required to implement on a smaller or private scale, the same modules using prefab concrete or bamboo can be multiplied depending on the geographical context. Affordability. Visraya aims at achieving the capital expenditure within budget. Capital budget given by a project partner, Selco Foundation, is for the build structure is 22 lakhs, where the baseline estimate was 20 lakhs 50,000 and the proposed model estimated was 18 lakhs 22,000. For that, the following are the measures and strategies for right sizing and optimizing of the systems and help to control the potential increase in cost of high maintenance, performance buildings incorporated in the project. Use of local materials and techniques. low transport and material cost, use of local labor and material cost, the low use of local labor force, provision of natural ventilation, multi-purpose spaces, creating multifunctional spaces with limited construction cost for maximum utilization of structure in disaster and non-disaster states, on-site solar-powered systems, effective rainwater harvesting systems. The design model opted business model, design, build, finance, and operate. In the DBFO structure, the Selco builds and operates the facility with the prime goal to recover the costs of investment and maintenance while trying to achieve a higher margin on the project. There is no actual ownership transfer. The Selco is responsible for the design and construction of a piece of the infrastructure for the mission community. Moreover, the private entity has the responsibility to raise finance during the construction and exploitation period. After completion, they hand over the project to the community. Design is developed considering passive strategies instead of the active ones, which will lower the repair, maintenance, and utility costs to achieve a better life cycle cost. Passive design strategies for ventilation as well reduce the electric load and hence reduce operational costs. One of the major strengths of the site was its immense solar energy potential. On-site powered systems, as our project partner, Selco has provided us a wide range of projects like rice water, hullers, a solar water pump, solar lighting system. Solar powered system costs around 10 to 12 lakhs. Integrated energy centers are solar powered community centers that can host a range of basic services and activities lacking in an underserved community, cost approximately rupees 50,000 for 15 lighting systems. Next, innovation. About 70% of India's total population lives in the rural areas. More than a third of the water available to them is undrinkable. Several states have reported multiple contamination of drinking water, and there is no doubt that the current water situation in India will get much, much worse unless proper solutions are found. So which makes this water filter unique in the use of bamboo charcoal, which is locally abundant product and nature-based solution. During water purification processes, bamboo charcoal even dissolves its rich mineral content into the water, so the purified water becomes mineral rich. Besides the use of bamboo, they also suggest the use of gravel and pebbles in various stages to aid in particle settling and hence further purification. The process is indigenous, environment friendly, inexpensive, and requires minimal maintenance. It can purify 30 liters of water per hour using a batch process under maximum sun exposure. The solar bottle bulb directs impoverished populations living without electricity. Water is first cleaned by a basic screening process and UV filtration. Bottles are filled with filtered water and alkaline substance. This water refracts sunlight during the daylight and creates same intensity as a 55-watt light bulb, making daylight affordable and easy. This saves electricity and provides a way of lighting for those who cannot afford it while keeping homes secure. Modules. The plan is divided into multiple modules ranging from 25 to
Thank you,
60 feet
team.
square.
I'm going to ask you to stop now. Your 25 minutes are done. And
Thank
over to the jury. Yes, so let's hear their comments. Alok, I'll start with you. You can go ahead with your questions.
Yeah, so again, congratulations, Monica, Komal, Mansi, Anuja. I think your solution, your design was very well done, particularly I think as it relates to water performance, as it relates to energy performance. I think you had some very good solutions that you've designed. So I thought that the quality of your design development process really came through. Um, I did have one question in terms of, you mentioned the design, build, finance, and operate model, and it was not clear to me in terms of what is the source of revenue for the project partner, for the finance, for the operation part of it. So if any one of you can maybe just make that clear. It would be helpful.
Hello. Am I audible? Hello. Yes. So they build the design and give it to the communities there locally, and they run the private communities there, known as Gaon Buddha, run the shelters, and then they give whatever the income is come is divided up with by the Selco partners projects. So this is run and designed for communities.
Okay. Okay, all right. I do want to say, I mean, I was very happy. Just one last remark. I was very happy to see the proposed design cost less than the baseline design. And I think that, that's where we want this to go because, and I saw in your slide also that you brought out what the cost reductions were. So it did seem to me, even from looking at your report, and it's clear from your presentation as well, that you've got the integrated design piece right. And I do want to congratulate you all for that. So, yeah, so I think I'll hand it over to my fellow jurors.
Yes. Thank you, Alok. Anamika, it's your turn now.
Congratulations, team. It's a very well thought out project. Um, I can see that you've, given adequate thought to livelihood issues, to gender issues by addressing things like by including facilities like, agro processing, weaving units, seed bank, creche, etc. Also, I saw very clearly, defined design for non-disaster period and for disaster period. So that's a very positive sign. Also, like your hyperlocal approach to the entire design process, very using indigenous techniques. Your material palette is very local, and including using mats woven by the occupants of that space. So all these are points that stood out for me, the way you've thought out, you've enhanced the longevity of your structure by giving adequate thought to how to process the bamboo and its structural stability as well. Resilience has been addressed very comprehensively, whether it is provision for cattle, backup power, or sandbags. So yeah, great job.
Thank you, Anamika. Surya, over to you.
Yes, great job. Lovely to see that there is a certain, clarity of where you're operating in the sense as a project developer. In the sense that you it's a very interesting hybridization of the concrete and the um, bamboo as the local material and the crafts that are available. Normally, what happens is once you start with concrete, you end up with concrete all the way, and it's nice that you know where to stop. So it's you understand that you know where it is needed, and you've taken it for that. It is a high embodied material, high energy consumption, high carbon footprint, but you know where it is necessary. So I think that's a very good decision there that you did that and you stopped and you took that. And when you actually use the local materials, you try to keep it the language of the material in semblance with probably what's local in that sense as a construction system, which is so there is a certain sense of comfort with the locals when they are there for the next 10 days or 5 days, whatever during disaster, so they're comfortable during that time. So it's that psychosomatic kind of quality that would allow. So I think largely that sense is very good. Couple of things. It would have been nice, and the ventilation systems, the natural ventilation dependence on that, as the way the form, the U-shaped form, allowing making it thinner, and so allows better cross ventilation instead of a solid, strong square form where cross ventilations tend to be not so good. So all that is well done. Um, what is not clear is how will the animals be safe when the bund, because the bund, you show the water coming up to the bottom. That's, I would say, it should be at a point in which it is beyond disaster, like it's one of those high-end disasters. But otherwise, your bund would have secured your cattle in the space below. But when the water comes, where does the cattle go? So that's something that's not very clear in this
Uh,
presentation.
can I reshare the screen?
Please.
Okay. One second. Is my screen visible?
Yes, can you go into presentation mode?
Yes. So, answering to your question, sir, the cattle are shifted to these two shelters. This one shelter is catering to the cattles, and the other one is for the pigs. So they are also on the stilts of about 6 feet high. So these two shelters are made completely in bamboo. Otherwise, which will be used as dairy units, where the cattle's milk will be produced, and they could sell. The villagers could use it as a source of income for them. So during the disasters, the
Okay.
cattle will be shifted in this place.
But so is this above ground?
Yes, it is above ground. So it is typically what in bamboo they do. It will be in a more stronger way in the cross bracing with the cross bracing.
Okay. I mean, as long as
So
there's a
this is
thought. I mean,
completely in
obviously, it
bamboo.
needs furthermore.
Yes.
Yeah, that's all right. Basically, there is a thought that you have a space but I think we should have talked about it a bit more in terms of class. Also, the bund. Couldn't the bund have been such a way that you actually have to go up the bund and then go into the project? So only in case of extreme disaster does the water get filled up inside. Otherwise, you could have a solar pump that would have actually pumped the water out in normal rains, and you'd still have a dry ground around your project because the bund would take care of that. So that was just, these are all small things which can further refine your project. It's not about that this is a big problem here. It's just a small thing, because otherwise there's so much other things that you've really thought through well, and making this work. So I think I'm quite happy with what you've shown, and wish you all the best.
Thank you, sir.
Thank you, jury members, and thank you, Team Styrium. You did a great job.
Thank
Thank
you.
you.
Thank you so much.
Thank you so
Thank you.
much.
Our next presentation is from Team Synergy. They have worked on Project Ahana in Odisha. Their project partner is Selco Foundation. Team, let's do a quick AV check. Hi Vidya, can you turn on your mic and
Hi.
say something? Yes, great. Hi Swara.
Hi.
Great. Hi Pratik.
Hi.
Yes. Hi Nandini.
Hello, ma'am.
Yes. Uh, Team, if you can share your screen and go into presentation mode. Okay. So
Sorry, ma'am,
team,
I couldn't able to hear you.
am I audible now?
Yeah, ma'am, you're audible.
Is
Yeah.
my screen is sharing, ma'am?
Yes. Just wait a moment. Team, you'll be having 25 minutes to present your work to the jury. At 20 minutes, I'll ring a signal like this. You won't have a 26th minute, which means at 25 minutes, I'll stop you and ask you to end your presentation. After that, we'll have a 15 minutes Q&A session. So please keep your answers direct and to the point. And your 25 minutes starts now. You can start your presentation.
A very good afternoon. Greetings to all the members of the jury panel, project partners, audience, and all present. Next slide. We are Team Synergy, a multidisciplinary group of sustainable designers, architects, and engineers from MSAP and MIT at Manipal Academy of Higher Education, Karnataka. Next slide. With Selco Foundation as a project partner, we were given a site at Pentakota, Orissa, to develop a community resilient shelter for the fishermen's community. The site is located in between the congested slum with an area of 1,560 square meters with a setback of 6 meters along the perimeter of the building. The harsh weather and the cyclone prone conditions make the need of the shelter to be indispensable. Next slide. We were successful in achieving 10 of the 17 Sustainable Development Goals. While formulating our goals and strategies, we kept in the integrated environmental planning using water, energy, waste cycle, and the principles of co-housing resilient shelter, and aimed for the interactive community along with the socio-economic development ideas. Next slide.
Though it's a climate responsive building, understanding the weather condition of the particular area takes the huge part. The building is located in warm and humid climate according to ECBC, so there is no heating required for the building. And the eastern and the western facade receive the equal amount of solar radiation throughout the year, and the glare-free light that we get it from the northern facade that can be utilized. We are suspecting from the June to September is the monsoon season of that period, and that particular area, and that time the building will be 100% occupied. So we did a sun path analysis for the latitude and longitude of the particular region, and with that the bandwidth that we have got with the solar window that helped us to understand how much shading is important for this particular building, and also the eastern and the western facade of the building will be hot and uncomfortable for the poor climatic condition. So to reduce the solar heat gain, we have gone for the we have the longer facade through that direction. So a lot of design strategy has to be given for the horizontal shading angle, the vertical shading angle. With the help of that, we came up with the length of the overhang, width of the overhang, and the depth of the overhangs. So in this monthly monthly timetable chart that we can see that the majority of the dry bulb temperature is high and it's completely red, where that we can suspect that we could able to understand the majority of the part is red and it's beyond the thermal comfort. Approximately 7 months from 6 a.m. to 6 p.m., the building is completely exposed to the sun, which helps us to understand the how much HSA and VSA has been utilized for this particular building.
Our site is a cyclone prone area, and weather conditions here make the need for resilient shelter inevitable. It's surrounded by 50,000 people living under a thatched roof, and currently the site has become a wasteland surrounded by crowded slums, which would be further converted into community resilient shelter for accommodating around 200 people. Next slide. Our project name is Ahana, a community resilient shelter. So our main goal is to build a resilient shelter for community benefit, which goes along with net zero energy and water. So as we enter the site, the building has tilt floors, which is connected to three floors above. The first floor has common amenities. Second and third has multipurpose halls and dormitories. Next slide. This is a walkthrough of our design where it shows the stilt floor with a respective floor above it. We have provided the stilt to avoid flooding on the ground floor during floods. The facade details with material representation and the overhang of the building are visible. The first floor. The entrance of the building is via a ramp and a staircase above the stage level leading up to a common corridor. It accesses the admin and then pharmacy, but that remains as such during non-disaster times. The reception has a seating area and accesses the medical area as well as a common space. The common space will be used as a multi-purpose hall during the non-disaster times, and during the post-disaster time as well. It's used as a healthcare or like food distribution center connecting to the dining area and community kitchen. All the spaces in this floor layout continues the same function during the non-disaster time except the multipurpose hall during the post-disaster time. The second floor and the third floor consist of two dormitories. The second floor dormitories are for the women and children and the above are for the men. So these are connected by a common multipurpose hall that doubles as a dormitory if needed. The dormitory above the medical area is being converted into isolation space in case of pandemic. So during the pre-disaster time, the dormitory could be used as a women workshop and Anganwadi as well. The next slide. This is an ideal workflow for scalability consulting. So at the design initiation stage, we need to set a baseline and target with comfort site analysis. As you move into concept design, we get into massing and orientation. Then comes develop design. So here we look into envelope optimization and system optimization, like what kind of system to be used. Then detailed design, where we get into detailing of energy modeling. And during construction, if there any deviation from your tender document or from the design, for that we use fine tuning and minor changes. Then finally, handing over to the commissioning. Next slide. We have done site analysis, SWOT analysis, and climatic analysis for the pre-project. Then coming on to the concept design, where here we evaluated different options. And then design development comes. So here developing the design and creating the idea of the structure comes in place. Then detailed analysis for the shading elements, facade, and specification are done. Documentation where the whole process of analysis is documented. And then helping the client and design team for procurement. During the construction, we need to make sure that all the practices are followed properly. Commissioning, the energy systems are very important. So if we have designed the building, the best building, but not commissioned properly, we will lose the efficiency. And then the net zero building is developed at the end. Next. Our project will function in three stages. The normal, that's a non-disaster period, the pre-disaster, and then the post-disaster periods. The pre-disaster time, there will be workshops like Anganwadis and workshops for the women, which will be converted into occupant shelter and then dormitories during the pre-disaster time. Post-disaster time, the main function of the project is to provide help and support to overcome the disaster loss. Next slide.
Coming to the innovation part, our team's prominent innovation is CSEB block with pyramid hub projection. It is used on the outer facade of the building. The hip projection helps in self-shading, which reduces the heat gain inside the building throughout the year. 50% of each block will be shaded all time throughout the day. Other than that, the available ground coverage of our site, including the setbacks of 6 meter on all sides, was minimal. So we have maximized the FAR by extending the floor area on the second and third floors on all sides, which not only increase the usage space for the community, but also acts as a self-shading element for the below floors. Next slide. The proposed construction budget for the project from the project partner was 32,000 rupees per square meter. This was excluding the operational costs, landscape, and internal works. They also allowed us to be flexible with the cost as it's a building that would withstand disasters like floods and cyclones. So finally, our proposed cost came around 72,000 rupees per square meter. This was including the landscape, interior works, and everything. Though the capex is high, the opex will be less, and the internal rates of return expected to come around 15%. For the reduction of cost and increase in the income for the community and the maintenance of the building, we considered minimizing the circulation area. Each space provided is used as a multi-purpose area. The source materials are local and doesn't require much of craftsmanship. As it is an RCC frame structure, it is easy to construct and reproduce. The kitchen gardens provided in the setbacks help the community grow their own food during non-pandemic times that can be stored for during pandemic times. The women self help group during non pandemic times can earn for their own livelihood, which would help them move towards a self sustainable society. Next slide. As of health and well being, the fishermen are exposed to the local climate throughout the year and they are used to it. As the building is also located in the community itself, we have maximized the natural ventilation inside the building to provide thermal comfort. We have considered mechanical ventilation only for during worst cases when thermal comfort is not achieved. The temperature goes high during the summers, which is during the non disaster times where the usage of building is minimal. Whereas during the disaster times, the thermal comfort and the air quality inside the building is not sacrificed. Next slide.
Our project Ahana is designed to achieve an EPI of 53.25 kilowatt hour per year with an optimal comfort and targets to achieve net zero energy and water performance. It is designed to withstand cyclones and floods with its structural and functional durability and have worked on the health and well-being by ensuring indoor air quality with the thermal comfort. Next slide. Coming to the resilience part, we have noted down these following problems and strategies. The first problem is the damage of lightweight roofs due to the high wind speeds. The strategy we came up was the roof pitch is to be kept at an angle of no less than 22 degrees. Second problem was the failure of walls due to the extreme wind force. So the strategy is use of reinforced concrete bands at different level, which will help to reduce the wall failures during the strong wind force and earthquakes. The third problem was interruption in the supply of food during the disaster, and the strategy is setback area can be utilized as cultivable area for food and medicinal crops, which can be used during the disaster time as a backup for short duration. Next slide.
So one of the other most challenging part that we had to design the energy generation, renewable energy generation for the entire building. Considering the climatic condition of Puri, Pentakota, the maximum hours of the sunshine throughout the year will help us for the uh, efficient solar panel for the energy that can be accumulated and that can be used. And the Pentakota also is exposed to hurricane and also for the heavy monsoon rains during the period that the amount of solar energy consumption can be reduced to 30%. At such times, the wind turbines can be used. And the type of the wind turbine that has been used is H type, which is made up of glass fiber, which is less in weight and more durable and also cost efficient.
To make our building a net zero energy building, we started with the base case model, for which the inputs are taken from the ECBC code compliance as mentioned in the table. As we can see here in the line graph, we initially checked if the model is working. As we can see, the cooling load is going high only during the occupancy time from morning to evening. Rest of the time, the operative temperature is higher than the outdoor temperature. This proved us that our base case model is working. In our base case model, we have used ideal HVAC systems with COP1. Next slide.
So, to reduce the energy consumption of the building, we came up with energy conservation measures that will help us to reduce the energy, that will help us to increase the energy efficiency of the building and make the building as high performance building. For that, we have came up with 5 energy conservation measures, which is envelope. We worked on envelope, orientation, window to wall ratio, shading, and efficient lighting and HVAC with the good LPD and EPD. So the first energy conservation measure we have took us for the envelope, that is to reduce the sensible heat of the building. which impact the difference in the temperature, which is with delta T. And considering these things in the roofs, walls, and the windows, the best U value and the thickness of the material has been chosen. Here we can see from the base case to the ECM1, the EPA reduction is 183. That has been helped us to reduce from with the help of envelope, and also we have kept the coefficient of the performance of HVAC as 3.2. So we can see the EPA difference as 183 from base case to the ECM1. So there are four cases that we have taken for the combination of walls. With walls, we have the best case that we have taken is the best strategy that we have also included, which is the pyramid hip projection on the outer facade, and the brick is made up of CSCB. And also we have the insulation between the outer and the inner wall, and the inner wall is plastered with 10 mm plaster. And for the same thing, how we worked on the wall, we have worked on the roof also, which we have kept the target as super ECPC. So we have that helped us to reduce the U value of wall and the roof. So same like for the window, we have gone for the four different cases like single glazing or the double glazing. We didn't opt for the triple glazing, though the cost efficiency investment of the cost is too high. And the best case that we have taken for the window is 6 mm glazing on the both the sides with air gap inside. So this is the best case that we have taken. You can see that the wall is the pyramid is projected on the outer facade of the building of the entire surface. So throughout for the entire building, whatever the solar window is, the heat gain and the solar um, gain inside the building will be projected throughout the solar window for the 50%. The second energy conservation measure, we have adopted ECM1 and the ECM2 both aspects. For the orientation, we couldn't able to play much with the orientation because we have to achieve 100% ground coverage for the building. So we have came up with the massing of the building, where for the case one, we have kept courtyard in the middle, and the second case was rotating the building to 15 degrees. And the case number 3 was we projected the building on the western facade as it has a lot of solar radiation inside. And for the fourth case, we have taken the projection on all the sides as 25 centimeter. And the fifth case, we have taken as projection on the 1 meter on all the facade. So the best case that we have got is projecting the building 1 meter outside for each floors. That helps us for the best orientation, and it has reduced the EPI as well. So the best EPI that we have got was 141 for including the projection of the building. So also this helped us to increase the built up area as well.
We have considered WWR as our third ECM, as this would play a major part in the heating and lighting load of the building. We have considered 9 cases in which on all sides we considered 40, 30, 20 and 10%, then with north 40% constant and changing the other side to 30, 20 and 10%, and finally with north 40% and east 30% as constant and changing only the south and west. As per ECBC complaints, maximum WWR can go up to 40%, and hence we didn't go beyond that. Considering only the API to find the best case felt absurd, as WWR with 10% came as the best case. Though the cooling load decreased, the lighting load increased. So we compared only the cooling and lighting load to come up with the best case, where we compared and neglect the worst case step by step. Next slide. After eliminating the worst cases, we felt the cooling and lighting load was satisfied in north 40% and other sides 20%, which was taken in our project. We have also used lighting and occupancy sensors to reduce the energy usage. Next slide.
So the fourth ECM with respect to all the three ECM that we had, we combined that, and the fourth ECM was the shading. So we couldn't able to play much with the exterior shading because the building is surrounded by semi-paka and kacha houses, and that doesn't create any big impact. So the self shading which also helped us, and also we have given the live shells and also the overhangs in the third floor, and for the ground and the first floor, we doesn't need it for the overhangs, as the building itself is self shaded. We have went for the louvers, that also helped us. For the east and the western facade, we have planted the mature trees that will help us during the summer and as well as the winters. So here we can see how we have given the vertical shading and the horizontal shading, and also louvers in the ground and the first floor. And we can see the EPA reduction that has been reduced from base case till ECM4.
As for strategies, we have used 4-star rated HVAC systems and efficient lighting fixtures. We use the approach of mixed mode ventilation in the building, and we have also used shelf shading. Next slide. With all these ECMs, we were able to achieve the target EPI set by Solar Decathlon, which is 59 kilowatt hour per meter square. From base case, we were able to reduce the EPI by 83%. This minimal requirement of energy will be obtained from the on-site renewable energy sources produced, making the building a net zero energy building. The target given by Solar Decathlon has also been achieved. Next slide.
Coming on to the water performance was one of our biggest concerns when it came to this project. Even though our annual rainfall ranges from nearly 1,300 per year, our occupancy load for this building is slightly higher than when compared to the building footprint. So, in spite of these challenges, we still achieved the net positive water cycle. So, strategies which we have used for efficient water performance includes first use of efficient fixtures by which we have brought down the water demand from 135 LPCD to 90 LPCD. Second, by recycling the on-site generated grey water to an efficiency of 75 percentage, by which we have attained net zero water. Coming on to the water consumption, so here we have considered around 200 people during the disaster time, and non-disaster time we have considered around 100. So the irrigation takes taken down from 3 liters to 1.5 liters, which remains same during the both disaster and non-disaster times. The water sources. So the rainwater is taken and filtered in a sand filter, which is then taken to a rainwater storage tank. Similarly, the municipal water is taken to the underground tank, which is then transferred to the OHT, that's the overhead tank, which is then distributed to all the respective users of the water. So the water is then treated with the root zone and chemical treatment. The black water goes to the settler and then to the municipal sewage line. This project is where we are only recycling grey water and not the black water. Next slide. Here we have compared the water consumption during the disaster and non-disaster time. As you can see, the blue tables are for the disaster scenario, and the yellow ones are for the non-disaster scenario. So the percentage in the pie chart of the both scenario is different depending on the activities done. For example, in the cleaning, it's 9.5 percentage during disaster, and it's 42.5 percentage during non-disaster times. Next sheet. The treatment process. So, as we spoke before, the majority of the filtration happens in the root zone treatment and not much in the chemical treatment. The plant Canna indica is used for the root zone treatment. So, after the root zone treatment, the water is chemically treated with flocculant and disinfected in the UGT of the grey water. So, when the treatment is happening, the chemical treatment, the flocculant removes all the colloidal and dissolved solid impurities. And then the disinfectant also helps in removing all the harmful microorganisms. Once this process is done, water can be achieved and standard quality can be later used.
Coming to the engineering part, the building consists of steel first and the second floor. The concrete mix is designed for M25 grade of concrete for the structural elements. The maximum size of the reinforcement bars used is 20 and 16 dia bars of 8 dia bars, which is used for the stirrups with 150 center to center distance. With 42 rectangular columns on of dimension 0.3 into 0.75 meter each and a beam of size 0.3 into 0.45 meter each, which includes the slab thickness of 150 The foundation mainly consists of 38 rectangular footings, of which 3 are combined rectangular footings. The maximum size of the combined footing is 6.95 meters into 5 and having a depth of 1.5 meters. For other footings, it is 1.9 meter into 2.85 meters with a depth of 0.6 meter. The building is situated in zone 1 and 2 of the seismic zone, which is in low risk zone. So we can say that the building is structurally strong to withstand the tsunami and cyclones, as we have the building 3 meters above the ground level. So the water won't enter the building envelope. The building edges are curved, which will help in diverting the winds away from the building. Next slide.
Based on the guidelines for design and construction of cyclones or tsunami shelters by the Ministry of Home Affairs, we discovered that the shelter need to be placed strategically on a grid-like format to ensure no one affected has to travel more than 2.5 kilometers to reach a shelter. And hence the site chosen is also inside the community itself. Using this to create a grind based on the population, we can build multiple modules throughout the area. As the community population is around 50,000, the module we created is for 200 people, which will be replicated with minor changes in orientation. The lack of elevation can create problems concerning the guidance for MPCS, which have been tackled by providing columns and starting with the stilt floor. The structure is RCC framed, which can be reproduced in less time. Next slide. As we know, sustainability is no longer an option but a norm. We also wanted to spread awareness through our Instagram page. We focus mainly on the young population in the age of 18 to 30. Our content has reached a wide population and is still increasing. We tried to involve the people with polls and gave them current updates with news. To know further more about us and sustainability, do follow us on synergy.solar decathlon in Instagram. Thank you. Ma'am, you're on mute.
Okay. Yes, let's take the jury comments now. Alok, I'll start with you. You can give your comments and questions.
Okay, all right. So yeah, Prateek, Nandini, Vidya, Swara, and your team, congratulations for having made it to the finals. I think you all did particularly well in my mind as it related to your water performance and your design for water systems. I think you also did very well with energy. So I did enjoy reading about your process for those. Um, I had a few small questions. So it looks like you do hit net zero energy. That is one thing that you've clarified in the presentation. Um, so can we just get a quick confirmation you do get to net zero energy because it was not clear from the report.
Yes, sir, we do get to net zero.
Okay, and I wanted to understand. When you say IRR of 15%, can you help me understand over what period of time were you considering? What does the IRR of 15% actually entail? I'm just curious about that.
So about that part, what we have did is we had a regression equation we have used for this internal rate of returns. And what we have did, we have taken the electricity bill of past 3 years of Odisha. With respect to that, we have calculated with the help of regression equation, we have calculated the IRR with the capex and the opex of the building. So with the help of that, we could able to achieve 15% of the IRR internal rate of returns.
Okay, so over what period of time have you assessed this? 3 years, you said.
We kept the lifespan of the building. We kept the lifespan of the building as 40. First is 40 years, 70 years, and 100 years.
Okay. All right. And I was also very curious about an image that you showed on slide 16. So I was just trying to understand what that was about. If you can explain. Yeah, the image on the right, what is it a simulation? What's the kind of, what are you trying to show here? On the left, image on the left, actually.
Sir, we are trying to show the summer condition of the building, like what is happening inside the building, the mean radiant temperature, metabolism, air motion, how like what we are considering inside the building for the health and well-being of the people.
Okay. Okay. And one last question. I don't want to hog all the time, but the self-shading bricks, I'm just kind of, I think self-shading as it relates to mass and volume of buildings in terms of the overall form of buildings definitely makes sense. But I'm I'm just curious if you had done any analysis of the self-shading of the bricks itself. I mean, how it actually kind of leads to benefit, uh, and if so, what is that benefit?
Yes, I
So
can
the
show a video.
two strategy that we have used for this self shading is the we could it able to play much with the orientation of the building from 0 to 360 degree. Our building itself is oriented from east to west, and we are supposed to achieve 100% of the ground coverage. So we want to reduce the carbon footprint of the building. So the ground coverage was less, and we have increases the build up. So that 1 meter projection of the all the facade of the building also helped us with the increasing the build up of the building. And the second is also the floors itself will be self shaded.
Okay. All right. Thanks.
Anamika, over to you.
Yeah, so congratulations for that excellent presentation. I appreciate your, correlation, establishing the correlation with the sustainable development goals. I also enjoyed, the way you walked us through the step-by-step analysis for energy. That has been a highlight, and we I was able to follow the energy use reduction logically. What else? You've paid good attention to structural resilience, considering the weight of the roof and, its pitch. Um, I just I was intrigued by this idea of co-housing that you mentioned. It caught my attention, but then I felt that you didn't kind of take it further. So, is there anything you would like to add to it? That is question one. And another, query I have is that did you at all look at the local construction techniques using the indigenous vocabulary of Orissa, which I believe is pretty strong, with stone walls or bamboo rafters or wood construction for the roof. Did you consider it and reject it? Because I know you're working with a very tight site with a lot of constraints. So if you could just clarify these points for me.
Ma'am, I'm answering your first question, which is about co-housing. We don't want to give much partition and feel everything is separated. So, with respect to the inner zoning of the building, we didn't give much partition between one zone to another zone, because it can be temporary partition can be made with respect to the pandemic which is coming in the future years. So that was the first aspect of giving the co-housing thing. And the second is, there is no discrimination over there in the building, so it's equal to all the genders, and it's equal to the all the people over the community.
Okay.
Over to you, Surya.
Yes, I think congratulations first to actually getting to this stage. A lot of hard work put in, consistently improving on the project in every delivery. It's a very good presentation. Couple of things which are very heartening is, one is that the idea of trying to innovate the shape of a brick, which allows certain kind of self shading. Obviously, it would have been useful if you'd taken it further, as Alok something mentioned about seeing whether it's really how effective this detail is, and accordingly, the detail could have been maybe improved. One doesn't know right now, but it's an idea-wise powerful idea. Similarly, the idea of self-shading of the form. The self-shading of the form is also very logical, given our country. Most of our heat gain comes from the sun. So, except your terrace, the others, at least the other vertical surfaces, get well protected. The terrace itself is another big challenge in our country, which is something that we can explore as we go forward. But the more interesting thing, which I'm very curious as to why you did not process you showed a very interesting process where you looked at the courtyard model, you looked at the shifting model, you looked at the overlap model. You had a very good slide here, how the architectural form developed. Very, very powerful slide. I'm very curious as to why you didn't hybridize couple of them. Like you could have taken the courtyard as well as the shifting out of the form, self-shading form versus the shifting of the form on the keeping the same column. So very curious because the courtyard, especially in a cyclone, you would have reduced your windows on the outer surface, and I mean, basically because the winds come at 200 kilometers. The last cyclone at Vishakhapatnam was 200 plus, and so which means as we go forward, 200 plus could be a norm for cyclones, which means very specialized high-end window which you cannot keep open, which basically are closed, and I mean expensive detailing. So obviously you can't avoid it, but you want to reduce that. So you would want to look at a form which would reduce your openings on the outer surface, and the courtyard, which is the safer, you could have actually had more windows. It's just a curious thing is why you didn't look at the hybridization of a form, or did that happen in given the time that you had to rush?
So time was one constraint, and again, like adding the courtyard will reduce the floor area. We had a minimal space. For 200 people itself, we had a minimal space. That's why we considered extending the floor area by extending the above floors. So giving a courtyard will again reduce it. So we had a second thought about not giving. That's why we didn't give.
Yeah, but I think that's where one has to balance this. Sometimes if it's okay if you reduce 25 people and you want to reduce half your cost, theoretically speaking. So
Yes,
you
sir.
have to balance these processes in that construct. And the the other thing is about the fishermen and their life. It's also important that in some of these slides that you talk about, you should talk about how your form or your ground floor, how the plan integrates that community as um, into this kind of a space. Because after all, the storm is going to last 2 hours to maybe maximum a day. The peak of the storm is normally 3 or 4 hours, 6 hours. The rest of the time, they'd still get back to normal. It may take them a few days. So they will end up using the spaces around and below the building before they get back to the room, the houses, or wherever. So that is something that one would have hoped to see the community and how the community informed the design. And just in the passing, uh, now our cyclone information systems have become very powerful. So whether we want to have a cyclone centers right bang in the center of the community or a little distance away, if you're able to get more comfort, it's all right because we know the cyclone's coming 2 days before now. I mean, all across this country, we've become very, very good in this. So it's just that you could have maybe taken advantage of knowing, unless it's some other kind of disaster, an earthquake, very difficult. But cyclone, you could. So you also now start looking at what's around and how you kind of work your form and your location accordingly. So otherwise, very well presented. These are just some thoughts out of experience we are sharing. Nothing to negate all the effort that you guys have made. Lovely effort.
Thank you for the
Thank you.
comments.
Thank you, sir.
Thank you, jury
Thank you, sir.
members. And
Thank you, sir.
thank you, Team Synergy.
So
Okay.
2:30.
Yes, we'll now take a long break for lunch, and the next presentation will be at 2:30 p.m. Team Tejasvi and the jury members, please join back at 2:20 p.m.
After that, what do we do after that?
After
Because we're
that,
done. We are
the
done. We are free.
yes,
Okay. Just wanted to confirm. Thank you.
I think
So
we'll
when do we?
deliberate on the final ranks, I guess, and then
Yeah, I
we'll
will.
give.
Yeah, that's the next question actually.
we can take that offline. Thank you.
All right.
No, no.
See you.
When do we meet for this final coordination?
After the last presentation gets over.
Okay, so we do that. So that's about half an hour of that time. Okay,
Yeah.
thank you.
Thank you.
All right. Thanks.
Thanks.
Hello everyone. Welcome back to the Community Resilient Shelter Division. We will now continue with our presentations. Our fourth presentation is from Team Tejasvi. They have worked on project Pancha Sahaya in Assam. The project partner is Seeds India. So now let's do a quick AV check for our presenters. Hi Vishal, can
Hello,
you
ma'am.
unmute and say something? Yes, great. Hi Vedant.
Hello, ma'am.
Yes, thank you. Hi Mehak.
Hello, ma'am.
Thank you. Hi Sukriti.
Hi, ma'am.
Thank you. Team, if you can share your presentation and go into presentation mode, we can start.
Ma'am, Swarnya is also there. She will present the screen.
Sure, she's the- Are you in presentation mode? So, um, so Team Tejasvi, you'll have 25 minutes to present your jury work to the jury. At 20 minutes, I'll ring a signal like this. You won't have a 26th minute, which means that 25 minutes, I'll ask you to stop and end the presentation. After that, you'll have 15 minutes for your question and answer session. Please keep your answers direct and to the point. Okay, team, your 25 minutes starts now.
Good afternoon to all the jury members. We are Team Tejasvi. I, team lead Mehek Gupta, with the whole team worked on this community resilience shelter for 9 months to make it a safe and comfortable space for local people during hard times and also tried to make it environmental friendly. We are a rainbow team as we are a bunch of students working together from different colleges and streams under one umbrella. We worked on this shelter with Seeds India. So we hereby present our community resilience shelter Vancha Sahaya.
So our design aims at encouraging the women of Mising community to become self-reliant in terms of income by providing a workspace for bamboo weaving, and also that space would manifest emotions of harmlessness and effortlessly adaptable by local people during and pre-disaster. And hence the name Vansha Sahaya in Assamese, which means a helping hand for the community. Our site is located in the Nikori village, West Block Bokaghat of Kolaghat district, Assam. The local people there are predominantly of the Mising community. It is an indigenous community inhabiting parts of Assam and Arunachal Pradesh, which gets largely affected during the flood months. So, in order to make the structure acceptable by local people, our challenge is to imbibe the essence of the characteristics of this community into our design. And based on our SWOT analysis that we did for our site, we analyzed the most suitable foundation considering the high water table and presence of khadar soil at the site is pile foundation with its spire depth having 7 meters. Secondly, the second observation is that the artificial contours are also designed with the help of soil that we get from excavation, which can resist the impact of initial wave of flood waters to some extent. Then, starting with the orientation and form development, it is done in consideration with the remote site analysis we did. The form is taken geometric to ensure optimum use of space, and every single square meter of site would be in service to the inhabitants. The facade is oriented 45 degrees to face the northeast direction with bamboo woven jali to ensure maximum daylight and natural ventilation to the inhabitants. And accordingly, the placement of the service core, namely toilets and staircase, are there on the southwest side, exposed to maximum heat, with solar energy as the only possible renewable energy that we can utilize to meet the energy needs, considering the site context. Then, moving on to the area statement, the permissible built up at the site is 817 square meters, and we roughly exhausted the same by covering 810 square meters, ensuring 2 square meter per person, according to the Assam Notified Handbook for Disaster Management. So, the site requirements comprises of a multi-purpose community space, a toilet with a soak pit, and a raised pump, considering the scale of the site, making this two-story structure capable to provide shelter to roughly 120 people at the time of disaster. The stilt floor plan over here is raised at a height of plus 2.1 meters with a provision of a specially abled ramp of slope 1 is to 12, which leads the people to this double heighted central gathering space marked with 3, plus a community kitchen marked with 1 is provided adjacent to a storage of food stocks. Then moving on to the first floor, which has individual dorms for male and female marked with 1 and 4, and the floor above it, which is the second floor, comprises of an electrical room with battery backup and storage of safety equipments like gloves and life jackets. And then the sectional elevation over here shows the section through the staircase, which ensures the safest vertical movement as water level rises up. Then the second section, this section is through the double height that we have provided on the first floor, which ensures the effectiveness of the stack effect for providing ventilation, and it also ensures visual connection between the first floor and the stilt floor level, so that visual connection between multiple floors is maintained, so that the people feel don't scared at the time of disaster. Then for better visualization purpose, here we have depicted the sectional view of the building at the time of disaster. Then the illustration over here shows the pre-disaster scenario in which the community hall is being used for panchayats and spreading information about government schemes. And the first floor is being used by local women as workspace to practice handicrafts, and also for them to promote and also for them for revenue generation. Then during the disaster scenario, this illustration shows the double height is being fully used for medical purposes, and for the safety of cattle is ensured by moving them onto the stilt level via that ramp, which is made of wood lumbers, which is accessible from the stilt level as well. Then the first floor is dedicated dorms for male and female, plus with a IT cell marked with blue to maintain communication with nearby health facilities at the time of disaster. Then coming to the resilience part of our building, in order to make the building resilient against flood, we have opted the wet flood strategy, in which openings are provided below the sill level so that water moves freely in and out of the building, so that it doesn't exert too much forces on the wall and the wall does not get disrupted. And the skin of the structure is like a sandwich between, in which bamboo bracing in middle and mud manure and cow dung layers are on the either side. This promotes resistance against fire. Then then for resistance against earthquake, we have provided steel bracing which ensures which will withstand the shear stresses of earthquake. Then under the affordability, coming to the affordability part, under civil cost, uh, we have used Zerand bricks, which are environmental friendly bricks and which has composition of plastic augments, and it is equivalent to 6 kiln bricks in size, and it is promoted by an indigenous startup of Assam, hence cost of transportation would be less. Then, following the vernacular architecture pattern and using bamboo and mud plaster on the envelope also contributes towards the cost efficiency. Then the design strategies that we have opted, like the service core is designed at a designated place, which reduces the additional expenditure on plumbing cost. Minimum cost on excavation on selection of pile footing. Then the multifunctional use of spaces like dormitories and community hall, and also the use of bamboo as its installation is as its installation is less time consuming, then the cost of construction would be less ultimately.
Here we discuss the cost effectiveness of the water and the energy requirements. From the graphs, we can clearly see that after using proper fixtures for the municipal water supply, we could reduce the cost from around 74,000 rupees to somewhat around 42,000 rupees. When we develop proper strategies for the grey water treatment mechanisms, we could reduce the cost from around 74,000 to 54,000 rupees. Quite similar were the cost reduction observations in the case of electrical cost management as well. We could reduce about 88% of our electricity demands from the solar panels itself with a reliability of only 12% on the grid source. We can see from the graph that the cost of electrical consumption was reduced from 25,000 to 2,700, with the reduction of annual electricity consumption from 3,600 to approximately 3,300 kilowatt hours. So while discussing about the energy performance, we will start by discussing about the renewable energy generation. We have utilized the great potential of solar energy in the region to produce the opportunities for the generation of renewable energy. The Golaghat region receives a solar irradiance of over 600 watts per meter square, thereby providing a great scope of renewable energy as solar energy. Our building has achieved an EPI of 59 kilowatt hour per meter square. For a community resilient shelter without having any HVAC systems, the optimum range of EPI values is between 56 to 65 kilowatt hour, and our value fits well within this range. We have set up a solar energy plant which has the capability of producing 4,000 kilowatt hour energy annually. Our annual energy consumption is somewhat around 3,700 kilowatt hour, and thus we are on a net energy positive margin by a value of 6.9%. We have reduced our energy consumption by a margin of 50.3%, and we have reduced the daily energy consumption from 10.7 kilowatt hour to 5.35 kilowatt hour. We could reduce such amount of energy by working upon small yet efficient measures like setting up of proper value of window to wall ratio, that is around 1 by 6th of the total room area, and changing the single glazed windows to the doubly glazed windows. We have been working on energy positive side because of not using HVAC systems in our building. The site has such a climate and the building has been oriented in such a manner so that we can work throughout the year without any HVACs. We have utilized the PERC solar panels, which have great advantages over the other kinds of solar panels. The PERC solar panel reflects the light back into the cell and increases the amount of solar radiation that gets absorbed. Since our site has a limited area, therefore the major challenge we faced was to produce out the optimum energy out of this limited area, and for this problem PERC solar panels comes to rescue. PERC solar panels allow greater solar energy collection in a smaller region. They also excel particularly well in both the high heat environments as well as the low light environments, with about a 3% increase in the efficiency. We have utilized the maximum power point tracking algorithm for maximizing the incident solar energy. This algorithm helps us to capture the point of maximum solar energy available. It prevents the oscillations of power, which is quite evident in case of some of the conventional solar tracking algorithms. It also has some greater advantages over the conventional algorithms, which is that it makes a judgment on the maximum power point tracked on the basis of the directions of the power, voltage, and the current. In case of engineering designs and operations, we have done efficient lighting simulations which help us to know the places where we need to have more lighting and the places where we need to have less lighting. Another important aspect of the engineering and engineering designs and operations is the use of power grids. We decided to utilize the best available power grid so that we are able to store the energy and produce it in the most efficient manner. Thus, we chose a 27 kilowatt hour battery pack system, which helps us to provide a battery backup of around 35 hours during the case of a complete blackout from its 100% state of charge. Thus, we decided to use the flow battery management system because it has various advantages. Flow battery management system has very less power loss and degradation value. It has no such inherent lifespan limitation for the energy being stored, and it is also assumed to be the ideal choice for merging with the solar cells. We are also utilizing the active battery management system along with the MPPT guided solar panels, which ensures a proper storage of energy in the battery and very less energy is wasted while charging the entire battery.
Golaghat district of Assam is very much prone to recurring floods that not only brings devastation in the livelihood of common people but also makes them deficient to access basic necessities such as clean drinking water. This challenge has inspired us as a team to think innovatively and to come up with ideas and solutions to ensure clean, safe, and sufficient drinking water for everyone. So, we are successful in achieving net zero water positive cycle. Our representative diagram shows the same. So we are having rainwater harvesting and municipal water supply as our sources of fresh water supply on our site. We will be using fresh water for the purposes like cooking, bathing, drinking, washing and cleaning, etc. The grey water generated from here will be sent to the treatment mechanism where it will be primary treated, then it will send to secondary and tertiary treatment, and then 70% of the treated grey water will be utilized for flushing demands. Black water generated from here will be sent to septic tank before the discharge. We are harnessing 498 we are harnessing 498 kiloliter of rainwater annually and 630 kiloliter of grey water annually through our treatment systems. Since our shelter is a community resilience shelter, water consumption at the non-disaster time will not be much. So now coming towards the analysis part, so our base case annual consumption is 135 LPCD and our efficient case annual consumption is 95 LPCD. So we have been able to achieve this reduction in percentages by the use of efficient water fixtures like aerators and dual flush toilets. Here in the graphical representation 1, we can also see the same where we have represented our base case and efficient case annual consumption in liters. We can clearly see that the reduction is about 27%. Also, from the pie chart, we can see that 52.8% of our primary demand would be fed by the treatment system, which will ultimately help us to reduce the dependence on municipal water supply. So now coming towards the water treatment system. So we are providing cost effective solutions that are highly efficient as well. So for the treatment of grey water, we will be doing grey water treatment in the three steps. So first will be primary treatment, second will be secondary treatment, and third will be tertiary treatment. So for primary and secondary treatment, we will be using tanks that will consist of multimedia filter bed and activated carbon filter bed. These filter beds generally consist of constituents like charcoal, silica sand, fine silics, pebbles, and gravels. This is an ancient technique which naturally filter out all the impurities from the water and also remove foul smell from the water. Still, the water from here will be passed for tertiary treatment where its disinfection will be done to remove all the traces of harmful bacteria and viruses. Now for rainwater harvesting, we are doing rooftop rainwater harvesting. So water falling on the roof will be collected and will be filtered through the filters. We call it as rainy water filters. So rainy water filters is a cost effective modern age technology which consumes zero power. It has a feature of automatically filtering out all the debris from the rainwater, and then it is not only just cost effective, it has easy installation process and takes low maintenance as well. So now talking about health and well-being, we ensure that every person living in our shelter maintain a good health. That's why we have provided exterior jalis on the first floor as well as exterior windows to ensure good air ventilation in our building. We have limited the use of concrete material in our shelter and had replaced 80% of the material with bamboo to ensure reduction in carbon emission. The treated rainwater and grey water is maintained under the safe pH limits. We have provided separate male and female dormitories to ensure privacy of the people, and also we have done the comfort analysis of our building from where we have analyzed that the optimum placement of the windows help us to keep our structure fully ventilated through cross ventilation. Also it helps us in positioning of lightning fixture. In pre-disaster time, the shelter will be used as a place to generate employment for the women with local artwork as well as to depict daycare. Daycare will also be provided to ensure well-being of the social community.
Now, talking about scalability and market potential, we worked with the sustainability of our project using Zeren bricks and bamboo walls. These materials lead to 50% reduction of weight of a building and makes it aesthetically pleasing. It also reduces the emission of harmful gases and construction time and also helps to promote local. Vansha Sahaya provides help to the community and generate its own revenue. To make it happen, our shelter collaborates with few organizations like NEEDS, Swarnirbhya Nari, and National Bamboo Mission and Atal Amrit Abhiyan. These are the organizations and campaigns which conduct awareness programs to increase market lineage, provide spaces to women to improve their standard of living, and can also enforce availability of bamboo. Sustainable development goals gives the direction and helps that each and every part is selectively catered to make the shelter eco-friendly. Now talking about innovations, next slide. Yeah. We try to enrich the sources and resources available to us locally to make sure that local people feel more cozy and connected during the hard times. For designing and structure, we use locally available materials, dynamic and adaptable spaces, and efficient multi-purpose buildings. For water performance, we use grey water treatments using multimedia filter beds and activated carbon filter beds. Effective rainwater filters, inline check walls, effective fixtures, and wet flood proofing is provided. For energy performance, we implemented maximum power point tracking algorithm and made use of the flow battery management and storage system. Moving on to communication, we have promoted our project on different platforms with the help of different social networking sites like Instagram, WhatsApp, and LinkedIn. Most of our audience were youth and stakeholders. The opportunities that we generated were COP26, team meetings, innovations, and reels. Now, we would like to give a vote of thanks to Solar Decathlon India for giving us this great opportunity and to Seeds India for providing us such an auspicious space for making this community resilient shelter. Thank you.
Thank you, team. That was a very insightful presentation. Now let's hear the jury comments and their questions. Yes. Alok, can you start?
Yep. Yeah, so Vishal, Vedant, Mehak, Sukruti, very good work overall. I I think that your design was among the most comprehensive in terms of its addressing the different contexts of the competition. Um, there's a lot to like in your design, and I do have one thought though. I mean, for all the great work that you did, I wanted to understand what was your analysis in with regards to thermal comfort, because I did not see any mention of that. I think that with a lot of the other remarks and the comments that you received, I saw those being addressed very well, in fact, in the presentation. But I just wanted to understand what went on with thermal comfort with your design.
Sir, when discussing about the thermal comfort of the building, the climate which is present at our site, like in Assam, and the orientation of the building is actually made in such a manner that we are able to work throughout the year without any HVAC systems, because we have a situation of humidity over there. Yes, that is true, but the entire architecture of the building is done in such a manner that the winds and the proper ventilation is maintained throughout it, that we are able to work upon the entire year without any HVAC system. So the effect of the thermal comfort is actually ensured by the proper architecture of the building.
Okay, so I just have one remark here. And I think that with every other requirement of every contest of this competition, you all have presented your solution in a very data driven, evidence backed manner. And this response to me just kind of falls flat because it's, telling me that take our word for it, the architecture takes care of the thermal comfort, which is okay. I think but yeah, I just wanted to kind of understand what was going on there. But otherwise, I think very good work. Yeah, I really do think that this team has done a very good job meeting and exceeding the requirements of a lot. And it's a difficult competition with a lot of requirements across the contest. So good job.
Thank you, sir.
Thank you, Alu.
Thank you, sir.
Now over to you, Anamika.
Hi, you've. I would describe your project as comprehensive. You know, you've addressed all the 10 contests with, you know, there's a lot of robust data and drawings and visualization backing everything up. However, I do agree with Alok that, you know, the way I enjoyed following the process through which you arrived at the massing and the volume, it was so you know, well documented. I would have loved to see that same documentation, and, you know, would have loved to follow that same thought process as far as your energy analysis is concerned. So energy analysis and thermal comfort do not match up to your own, you know, you've set your standards so high for all the other aspects of the contest that while they are good, you know, they don't match up to your own standard that you've set for the rest of the contests. Otherwise, you know, the I mean, I know that all the contests are equally weighted, but if we, for this particular section, if we say that resilience is what we are looking at, then you've addressed that very well with, you know, be it fire or, you know, bracing for earthquake or, you know, the wet flood proofing. You've addressed, you know, it's a very comprehensive approach. Same with your net zero strategy, which I was very happy to see that your engineering design is again very robust, and you've, you know, brought in PERC solar panels, the MPP tracking mechanism algorithm, and the flow batteries with its innovative storage system. All of that I was very happy to see. And you've introduced the Zerin bricks and, you know, detail your bamboo construction so well. The whole project has come together very well. It's visually appealing. The drawings are a pleasure to look at. The sections I've seen, you know, well drafted sections after a very long time. So congratulations.
Thanks a lot, ma'am. Really means a lot.
Thanks a lot, ma'am.
Now over to you, Surya.
Yes. Yeah. Yes, I guess a very well done presentation, because uh, I think you were able to communicate what you wanted to very well, which well, even from the earlier deliverable to now what we saw, and today, very good drawings, clear, and most important of all, that since you're looking at really resilience, and in that sense, already what Anamika has talked about, and along with what you have actually kept your scale of your project. You kept the scale of the project to a level in which it is really possible to do it with the community, with with resources that's available around, versus becoming too ambitious and wanting to kind of quote unquote create a new typology, which is I think the other fallacy that as architects or designers or engineers, when we get into solving a problem, we're also having this thing: what is unique, what is new here. And I think that you kept that restraint and you articulated that to the best, like looking at simple things like the walls, the bamboo bracing. I was curious, and I think I'll expect you to answer me something about the foundation, which is not yet very clear. Though you talked about pile, but when you see what's coming out of the ground, it's in your presentation, it looked like wood. So one wanted to be clear. One could discuss that a bit afterwards. Uh, the, the drawings clean, very clean. And somehow the cross ventilation, because you kept a very straightforward central core of movement, and you put two things around it, the project is very easy to handle and also flexible in terms of change of use. So what was, and I think what Alok already told you, I do wish that you had in some way figured out how to calculate the energy, I mean, radiation of those walls, because you used what's actually very common. And the problem is that because we do not have data on these things get thrown out of the window, and we come back to UPVCs and all kinds of insulations that are being promoted in the market. And if you can prove that through calculations and data that this is an amazing product in terms of reducing, I mean, creating insulation, I think you could probably, put this out as a product. So do go after it. Do not, even if, after this project, my strong suggestion is do go and get data on this, work on this. Yeah, it's very, very crucial information that's missing. So yeah, this is what I had, and I think if you can just tell me a little bit about the foundation, that would be nice.
Yeah, yes, sir. Sir, it is like since the water table is quite high and there are recurring floods, so we have gone for pile foundation, which is like our structure is completely load bearing in terms of like it's a frame structure with columns and beams taking the loads. So, what you asked
So the
about the
columns go up
foundation,
to beyond.
sorry.
No, after foundation, pile I understood. After the foundation, above ground,
Yes, sir. It is going up to the
after
first
pile,
floor.
what comes up? Yeah.
So the columns, like it's going up to the first
Oh,
floor.
so it's not wood. Okay, okay. Maybe then I mistook it. I looked at
Yeah,
the
right, sir.
presentation.
It
It
is.
looked like that's
Uh,
all right.
it's completely RCC, sir.
So okay, so it's a hybrid construction.
Right, sir. Definitely. Yeah. True.
Oh, so that's a pile.
Yes, sir.
Right.
No, that yeah, that's the drawing. Okay,
Right.
fine. It just looked like in your drawing, it looked like wood, so I was curious.
Yeah. Yeah.
No, because there is an interesting, very interesting solution that has been tried in swampy areas, flood-prone areas, which is they drive down casuarina poles. You have these casuarina plants, and they actually bang these casuarina poles one next to the other over a 1 meter square area next to each other. They just bang them into the swampy areas, and then over that they build a concrete footing, and then they put a building on top. So I mean, which is in the case of when they built in swamps areas, this has worked very well. And so I was just curious if you guys came across that. Yeah, so that's all right. So
Yes,
great,
sir.
great job. Only,
Thank you, sir.
yeah, please.
Yeah, sir, I just want to add on the statement you said. We just thought about the people there. Like, we didn't thought about this project just as a competition, but we thought as a community shelter which can actually be made and will be in use sometime in future, so that people there can like definitely feel there as home, because many people leave like lost their homes and lands for during these hard times.
Totally agree with this. Just that my little doubt. I actually think this is a better solution. Having a more permanent, non-maintainable kind of surface over which you build what you've done. So in that sense, the hybridization is very good.
Thank you, sir.
All the best. Well job. Well done. Well done.
Thanks a lot, sir.
Thank you, jury members,
Thanks a lot, sir.
and thank you, Team Tejasvi. You've done a great job. So, yeah, folks, that was the last presentation in the Community Resilient Shelter Division. Our esteemed jury panel has also shown a dedication to assessing these entries. I want to thank the jury members for your thoughtful assessment and comments. And I also want to congratulate all the finalists. As the jury coordinator for this division, I have had the opportunity to see these teams submit their deliverables 1, 2, and 3, and this final deliverable 4. They have done some incredible work. Let us not forget these teams have discovered a way to collaborate and do integrated design while being physically away from each other during the last 8 months. I think that itself deserves a very big round of applause. This evening, the jury members will decide the winner and runner up teams. Who will it be? Meanwhile, please make sure you have given your oaths for the People's Choice Movie Award and feel free to hang around and meet the other jury members and other guests in the networking zone in the lobby. And you can see all the work from all the teams in all the divisions displayed in the project exhibit hall. You can access the hall from the main lobby. And see you all tomorrow at 10 a.m. for another exciting day. Bye bye.
Hi. When do
Bye.
we meet? Where do we meet? The three of us.
On a separate call, I'll give you the information soon.
Okay. All right. Bye.
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 Bye.